Minasan konnichiwa. Redomondo wa gozen 10時なので、.NET API Review の時間です。はい。Google Translate though, I knew like half the words. All right. While we do have a red issue, it's shouldn't be, so we're just going to ignore it. And today we're going to talk probably entirely about AVX 512 and .NET intrinsic support for supporting that. So with that, Tanner, take it away. I guess starting with issue 73262 vector 512 for AVX 512. There we go.
Right. So the basic premise between the for this first one is, of course, we expose vector 64, 128, and 256 of T today. AVX 512 extends the existing hardware support to 512-bit vectors as well. So in order to be able to define those instructions and support them, we first need a corresponding vector 512 of T type. The surface area here is identical to vector 64, 128, and 256, other than taking 512 in all the areas that it requires. And then for the APIs that deal with the lower and upper halves, it takes vector 256, much as vector 256 takes vector 128, and vector 128 takes vector 64. You were going to say something?
Are the echo 1 through 32? No, through
63.
All right, yeah, are echo 0 through 63 the right names for these values?
Yes, we used E number for all the names for the other vector sizes. It just stands for element.
All right, if we did bizarre abbreviations in the others, then I guess it makes sense to keep doing it here.
Yep. So we've got the is hardware accelerated property, which notably should be static as the top member. We've got absolute value, which is supported for any of the primitive types. Add and not. The as method, the generic as method, which takes T from and T2, and then the explicit as methods, which target an explicit primitive type for all the supported types, including inint and inuint. We have the APIs that allow converting a vector of T to a vector 512, to and from a vector 512 for if and when it is that size, and which has well-defined behavior of zeroing the upper bits in case it's smaller, and truncating in case in the inverse direction. We then have bitwise and bitwise or, again matching the name, vector 128, 256 and others. They've got and not and then bitwise and rather than just and or just or, which in hindsight is somewhat inconsistent, but that's how it was with vector of T as well, defined back in 2014. We've got the ceiling methods, which operate just on floating point, so double and half. We have conditional select, which, much as the other ones, this does a bitwise conditional select rather than a per element. So the actual condition is used as a bit mask rather than an element mask.
Yeah, so I'm on the monitor that you can't see. I'm just scrolling down and comparing it to vector 256. So far, looks like copy 2 just came out of order. I was going to say, it looks like we're missing some copy 2s. Yeah, so is there really anything in this type that we need to look at? Otherwise, I think we can blindly assume that you always return the this when you should, and that all the sizes are right. So is there anything new in 512 that wasn't in 256?
The most interesting thing is probably extract most significant bits, returning ulong. So if you happen to be using 512-bit vectors on a 32-bit machine and you want to get an entire mask for it, that will potentially be more expensive, because it has to be represented as two registers or a non-registered value.
Would the AVX 512 instruction set even be considered valid in CPU flags in a 32-bit processor mode?
Yes, but
Okay.
notably, AVX 512 in particular introduced masking support, so they have special mask registers now. And so this is somewhat different from the actual move mask that that you would typically use on vector 128 or vector 256. But it represents the same logical functionality here, as in a general purpose cross-platform mechanism for getting all the bits as a linear value.
Regarding the masking functions, you're not exposing masking APIs here, correct? Because that I guess would be on the proper intrinsic functions, not on the generic functions.
Correct. There. So in particular, this one covers vector 512. The next proposal covers masking support via the vector mask registers. But neither of them get into exposing additional APIs that utilize those masks yet. There will be a separate proposal, which is not up today, which covers how the masking support gets used in AVX 512 directly. Although we'll discuss that a little bit today. And then there will be future APIs proposed for the vector 64, 128, 256, 512, and vector of t, which utilize the vector mask.
Okay.
In the case of vector of t, it will end up allowing us to safely expose concepts that we couldn't have exposed before due to its variable sized width.
Got it. And to the earlier point that you made, if I wanted, say, a 32-bit pmove mask B instruction effectively, it sounds like what I would do is I would take the vector 512, turn it into a vector 256, maybe like get low half or something, and then call get most significant bits on that.
If you wanted something on 32-bit and you only needed a mask for the lower bits, that would be more efficient, yes.
Okay. Is there any interesting consideration for this vector type, like getting the upper or lower 256-bit half, that isn't a direct analogy to, say, getting the upper and lower 128-bit half from a 256?
No.
Okay. So all the concepts just transfer over. Awesome.
Correct. It's all the same concepts, just 512-bit now, and done in a cross-platform agnostic way.
Okay, and it looks like the T one, aside from some typos, is balanced. Let's put the A in equatable. I guess the other A in equatable. And that missing semicolon. All right. Any feedback? I assume not, but I have to ask the question.
Just like everything else, if I'm on a normal, like if I'm on a processor that doesn't support AVX 512, the vector 512 is supported, it's going to return false, right?
So, is supported indicates whether the T is supported. That is, whether or not it will throw a not supported exception. So vector 512 bool would return is supported false, whereas vector 512 of byte would return is supported true even on ARM64. It's the vector 512 dot is hardware accelerated on the non-generic class that will be false when there is no hardware acceleration. So on a non-AVX512 hardware enabled platform.
But could still use these APIs. They just wouldn't be hardware accelerated.
Correct. And that's kind of the difference between hardware accelerated and supported. Is supported means that if you're trying to use this type, that it will just throw, nothing will work. And is hardware accelerated means it will work and it will work fast.
Mm-hmm. And we don't envision any scenario right now where, like, vector 512 of int will be hardware accelerated, but vector 512 of double will not be hardware accelerated, or some silly thing like that.
Correct. There's always some edge case considerations. Like on a 32-bit platform, long will be accelerated for like 90% of the scenarios, but there's a couple edge cases where it may be less accelerated or not accelerated at all. Like if it has to fall back to a division by non-constant path for integers in particular.
Okay, but it sounds like you have a pretty good idea of how we would communicate that through documentation in the API surface.
Correct.
Okay. And it also sounds like, just from my own understanding, that's not really an issue with 512, correct? That's just vectorization as a whole. Or is that specific to 512? Okay.
Correct. That's just in general.
Okay.
Integral division doesn't have SIMD acceleration on most platforms, and so we can only potentially accelerate it if you're dividing by a constant, for example. In which case you can do some of the same tricks that scalar integer division does to avoid actually dividing.
Cool.
Barrel shifting. All right. That was progress because we didn't have to think. So expose vector mask to support generic masking for vector 74613, and as of yet I see no chat from YouTube, so hopefully that there's no chat from YouTube and not that Restream is having difficulties today.
Vector mask is that as you get to larger size vectors, and as is the case with vector of t, where it's variable sized, you kind of need this concept of, I want to do an operation on some elements but not all of them. Prior to AVX 512, the only way you could do this was by explicitly getting a condition mask, such as by doing a comparison, and then using another instruction like blending or conditional select to basically do the relevant branch-free logic, so you could merge two results together. With AVX 512, the hardware has direct support for this concept, and it's able to do it incredibly fast, much faster than you'd be able to with explicit blending. And so we want to expose a new corollary to the vector types called vector mask. And for every single sized vector, there would be a corresponding vector mask of t. So vector 64 has a vector mask 64 of t. The vector of t has vector mask of t. 512 has vector mask 512 of t, etc. Where the hardware supports the direct acceleration, the JIT will be able to take advantage of this and directly map it to, for example, the K-mask registers that AVX512 uses. And in the other cases, we'll still be able to generally do a good, optimal, or correct thing by effectively deciding to use the relevant blend instructions instead, and doing various JIT optimizations to ensure that we only do the conditional selects as much as actually needed. So you can still use this to correctly accelerate when there is no hardware masking support. Likewise, in the case of vector of t, it's going to allow us to expose concepts like give me a mask representing which elements have the most significant bit set. So whereas we couldn't expose a raw extract most significant bits API, because someday we could have vector 2048 like ARM SVE has, and therefore we couldn't represent 1 bit per element within even an int 128 integral type. Vector mask allows us to abstract that and still return and report the relevant information efficiently without actually exposing the raw binary data, as it were. And so each of the vector types has a new API called extract mask, which will functionally get a mask from the vector, and it is functionally similar to move mask in that it just pulls the most significant bit from each element into the mask, which is likewise how kmask works for AVX512. Then the non-generic vector mask class, and then the generic vector mask of T struct, they follow namely the same general shape as the corresponding vector and vector of T types do. So we still have an is hardware accelerated property, which should have been static. We have the generic as methods, and then the generic to a concrete type as methods. We've got basic bitwise operations such as and, or, and not, one's complement, XOR. There's also a new API, XNOR, which is exclusive not or. There's shift left, shift right, equals, and then a few helper methods in the form of leading 0, trailing 0, count, and pop count. The elements, if you were to get them, would just be bool, representing the bitwise true or false for each element in the mask. And then for the concrete sized masks, there is a create API that takes in an integral representing the representing the largest number of bits available. So in the case of vector mask 64, it takes a U short, since you need no more than 16 bits to represent vector 64 of byte.
Wouldn't it take a byte?
No, because you need 1 bit per element. So you need 16 bits.
Where's the
Oh
U
no,
short?
you're right. You're right. That should be byte, and then vector mask 128 should be.
Sorry, which member are we looking at?
Vector. So the create method. Levi asked if it could just be byte.
Vector mask 64 dot create.
I think that should be byte.
I think you talked about it, but I missed it, or I didn't quite follow. So let's say we would never have something larger than vector 512. The largest mask we would expect would be a 64-bit mask, right? Or 128-bit, no, 64-bit mask. So
Right.
we could just use, like, we wouldn't need these vector mask types, right? We could just use ulong, uint, etc., and binary operations that operated over uint, ulong, etc. Is that correct statement?
Not really.
Okay.
So the reason why is that even though that theoretically would work, it does not map in a way that the JIT could easily handle for AVX512, where you do actually have a dedicated register type that's separate from the SIMD or general purpose registers that's used to actually hold and track the mask.
So given that, I mean, are we creating the vector mask 64, vector mask 128, and vector mask 256 purely for symmetry?
Yes. But also allowing a general extension for if any other platform supports them. So in particular, while KMask is an AVX 512 specific concept, AVX 512 includes masking support for 128 and 256-bit operations. So 128 and 256 actually need a direct mask concept as well because they can use the KMask registers. Vector mask 64 is the one that's actually truly for symmetry because there is no KMask concept or even vector 64 support on modern Intel hardware.
I see. Feels like a lot of surface area for that, but I get it.
Yeah, the XNOR is, and particularly the casing thereof, is the thing that I think is interesting because I don't think we have that anywhere. So we're inventing a word now.
We don't have that anywhere else, but given that we have XOR with the O lowercase, that was the logical extension because that's two words exclusive OR. And we always do it as X, capital X, lowercase r. And so in this case, I took it as we are representing the commonly named abbreviation as one word, and therefore this should be XNOR.
I guess that's true. It is well, I mean, really it's XO, and then we write the R, but yeah, if we look at it as a 4-letter abbreviation, then that would be the right casing. Alright, anybody object to that casing? Other than it looks weird?
My concern actually would be that people will accidentally call it when they intended to write XOR, and they'll wonder why things are weird. But maybe that's just a code review thing.
Yeah, and I'm unlike and not, where we didn't choose to call it, for example, NAND or anything, because and not is another common name. I wasn't able to find an alternative common name for XNOR, and I don't think X or not is very clear.
Right. Well, and not and NAND are actually different gates.
Yes, and we use it to represent the same operation here. And yes, indeed, x86 hardware and ARM hardware inverse which operand they and then we ensure that the cross-platform API does it consistently.
Oh, what I meant is A and not B is a different operation than not open parens A and B.
Oh, yeah. Yes.
Yeah.
All of that said, so I see that you also have concrete widths on all of these types. Like, is it common to take one of these and say shove it into, I don't know, an array or somewhere else in memory? And is it guaranteed that it will always be exactly 8 bits, 16 bits, blah blah blah?
No, so the actual size of these we're going to leave as an implementation detail. The 64 here indicates that it's a vector mask that maps to the vector 64. Maybe vector 64 mask would be a better name rather than vector mask 64. But it explicitly represents it's a mask for a 64-bit vector. And we may even want this to not be byte, but for example, just a vector 64 of T on non-accelerated hardware. Okay. That is where there is no K-mask, because for many cases, such as with blending, that is a better representation.
Sure. The reason I'm asking is I'm looking at the reference API that you have here, and for example, you have private read-only byte underscore value, which means that I believe like size of in C# is going to say, yeah, I'm I'm just going to bake it in as a constant. Like I'm not going to bother actually inserting a size of opcode.
No. So C# for any user-defined structs always emits a size of check and requires the unsafe keyword to do so.
Okay, perfect. Excellent.
Some user could theoretically try and depend on it, but this is something where we'd have to have an analyzer or recommend don't do it. Just like we recommend users don't create vector 128 arrays or vector of t arrays.
Got it.
You really want to have a t array and then use the vector type as kind of a ref struct almost.
Because it sounds like the way that all the processors kind of implement masks is architecture dependent, right? If I'm understanding what you're saying correctly.
Correct.
And we don't really want to get people into the habit of saying like, oh, it's always just, take the number of bits, divide by 8 or something.
Correct. And in particular, we only have to consider Intel's AVX512 implementation today, but we want to allow this to be used for better cross-platform acceleration, especially in the case of vector of t, where we can't represent some of the concepts without having this mask type.
Yeah, so returning to XNOR for a moment, why is it that we think it's important to have it on the mask type when we've never added it previously? And should the follow-up implicitly will be, should we be adding it on the vector types directly?
So in this case, AVX512 directly supports this instruction. Anthony may be able to give more detail on how it's used. I don't think that we strictly need to include it in the initial review. I also notably removed the add method, where AVX512 hardware has direct support for adding 2 masks, but not subtracting or doing any other operations. And the use case wasn't clear, so we said we'd add it in the future if and when the usage scenario became clear. And otherwise, devs could use the raw APIs for that functionality.
Yeah, that makes sense to me.
Yeah, when I added it in, I really followed along with what AVX512 operations are supported on the mask registers. And like Tanner said, we decided that add isn't necessarily needed to be there at the moment. So for XNOR, I mean, either way is fine.
Okay, through any of the ISAs, is there a SIMD XNOR that's not on the mask registers?
I don't think so today, and it's reasonable that we could recognize this as XOR with the relevant one's complement. Yeah, we could probably just recognize the pattern, at least initially.
Okay. I mean, so I don't really have an opinion of keep or cut. I just noticed things like it's new, so do we need it / should it be elsewhere? Anyone want to voice keep or cut?
Or XNOR?
Yeah.
I love it. It sounds like a Pokemon. Keep it.
There's our justification.
Levi, you had a comment in the chat about using a nested type for mask. Why wouldn't we do that?
Are you asking me? Because I was a fan of that.
We use nested type for other things. I mean, they're tightly coupled. Seems like a reasonable suggestion.
I mean, our hand wave starting point is if anyone ever needs to use it, it shouldn't be nested. But the more specialized your scenario gets, the less likely we are to care about how it confuses people in certain languages.
This is a case where people are likely going to need and want to type vector 64 of t dot mask all the time.
But we're talking about a dot. Like, it's not like it's adding a significant amount of overhead. It's, I want the mask that's associated with a vector 64 of t. And it's a question of whether we say vector 64 mask of t, vector mask 64 of t, or vector 64 of t dot mask. They're all not pretty.
Yeah, and if just pointing out, if we do think that vector 64 of t dot mask is the right answer, somebody who disagrees with that, at least in C sharp, can use a type alias. I don't know what VB and F sharp have,
But then you also have to have, so we'd have vector 64 dot mask for accessing all the static methods. So vector 64 dot mask dot create, for example. And then you'd have vector 64 of t dot mask to access the type, to be able to call the APIs.
Well, you don't need the static vector mask 64 or vector mask. You could put all those on with potentially different names on the vector 64, vector 128 types. Some of them as overloads of things that are, overloads that are either on vector 128 or vector 128 dot mask, and create mask, etc. It may be a different shape, but it might logically help keep things and the top level simple. You go to the namespace that has these, and you just see the main vector types, and then you dot into those to get their masks. And I think it's reasonable to explore what that design looks like.
It doesn't feel like how we've done types in .NET up till now.
Well, this whole area is pretty special, though. We've got types that have hundreds or thousands of methods on them. That's also unique.
Right, but we still have typically followed the normal shape and layout for most of these.
Yeah, the only related place I can think of where we actually did this is in the actual intrinsics themselves. We have like .x64 whatever.
Right, and those are expected to be less commonly accessed. Now, there is an interesting case that we're going to get to with AVX512VL, where we're going to discuss whether that should be a nested class or not. But for the type itself, it feels off to me. It doesn't, like, it's not a I would hate it type thing. It feels off.
I guess I'm trying to make sure that, as much as anything here can be simple, that the simple stuff remains simple, and that the top level isn't cluttered by the more complicated stuff. This is the more complicated stuff, and so if there was any way to sort of keep it hidden while also, associating it with the things that it should already be associated with, to me that feels better. My opinion could be in the minority.
At least in the case of vector 128, 256, and 512, when considering desktop hardware at least, the masking is likely going to be a little bit rare of a concept because most of the 512 support is on server chips. But with vector of T, because they don't have a way to get masking concepts otherwise, this would likely be a more first-class citizen that users would want to work with regularly as part of their code to actually simplify things more.
Where are the methods for these vector mask types that integrate with vector of T? Is that later in this issue?
No, that's going to be a different proposal. But they're so outside of the extract mask here, which allows you to do effectively move mask, but on vector of T. As well as the leading zero count, trailing zero count, and pop count that allows you to do things a little bit more generically. That way you can do some of the other core operations. There's likely going to be APIs that allow doing, for example, a load leading that takes a mask and a load trailing that takes a mask. That way you can easily handle the leading and trailing elements from a from an input that's not a multiple of the vector size.
And there'd be overloads of those for vector mass 64, 128, 256, and 512.
Right, that would be able to take a mask indicating which elements you actually need. And then, of course, with AVX 512 itself, basically every API from SSE up through AVX2, as well as the new instructions for AVX 512, all have an overload that take a mask.
I'm not going to die on that hill, but I still like the idea of grouping them.
I mean, yeah, I think the nested type is interesting, and remember that when we're talking about users of these types here, we're not talking, the billions potentially of .NET users. We're talking the like hundreds of intrinsics users, which still beats my like fives of crypto users. But while we don't want to be misleading with things, being slightly awkward isn't terrible. But given that, I think that even if we don't go with the nested type, that we probably want to switch the number in the mask.
Yeah, I definitely prefer the switching of the number and type, or the mask and the 64. So it's vector 64 mask. That also groups them, and I'm also not going to die on the hill of, don't have the dot. But my initial gut feeling is that it's inconsistent, and that it will be, it will make the concept harder for devs that need to use it to use.
Yeah, I know we have done some before. Since I'm hosting the stream, it's slightly complicated for me to search for instances where we would have nested types in public API that aren't just enumerators. But we have, and the more niche an area gets, the more likely we are to do it. So I think that we're in the gray area here, where if we think it looks better overall, then we can do it, and if we think it looks worse. So I'll leave a note that says that we'd like to explore it to see what it would do.
That sounds good to me. And then once we actually get the proposal up to show what the vector mask API looks like in more detail, we can likely do a little bit of a discussion on what they actually look like when comparing.
So with all these masks, do we expect that the places that we're currently using things like extract, whatever the API is called, leading bits, or whatever the API is named, do we expect that we would switch those over to these?
I don't think that's a requirement. For if we start looking at using vector of t in more places, because we are doing the discussions on how can we improve the downsides of vector of t. This is one of them. Another one is the fact that it's not considered ABI stable, so it doesn't work with ready to run or cross-gen or any kind of thing like that. If we start using vector of t more prominently, then we would use the vector mask of t in places where we're using extract most significant bits today. Otherwise, they should be identical code gen. And the more interesting case gets into if you start doing more complex masking, such as with load leading or store trailing or anything like that.
Sorry, why would they be identical code gen? I thought the point was that with using these special types, we'd be able to take advantage of registers with AVX 512 that we couldn't otherwise.
Right. But that's also AVX. So on AVX 512 hardware, this should be better code gen if you're doing something that would be able to take advantage of the masking on AVX512 hardware. Many of the cases where we're using it today is just a case of move mask, where we're not doing any kind of advanced masking. We're just trying to get a bitwise mask and then check if it's 0 or non-zero.
I see.
The AVX512 concept is more around merge masking, which would be more like you do a comparison and get a mask and then do a blend, for example, or a conditional select. And those are cases where if we're doing like a conditional select, we would want to look at using merge masking instead.
Okay, so I rewrote all vector mask 64 to vector 64 mask and all the sizes up through 512. We have the operations that are included here. I assume since these don't have, for example, addition currently defined on them, that they're not generically mathable. Generic
Correct.
mathable. Yeah. And
we also have a more general issue with generic math in the vector types where we'd like to be able to use it in some cases, like the scalar fallback, but due to the fact that you can't go from a less constrained to calling a more constrained scenario today, you can't, for example, do a if t is I number and then access t plus t. There's a language proposal open to allow that in the future, in which case we'd in which case if that happened, then we wouldn't really need to care what the constraint was here, other than it being where t is struck, because that helps with the JIT today, as well as is the closest we can get to the actual constraint without making it unmanaged. And we chose not to make it unmanaged way back when, I think, because other languages might not support it.
And I should have asked on the previous issue, because there's just this tiny bell ringing in the back of my head. Is there supposed to be some sort of attribute on his hardware accelerated that makes it like JIT intrinsic magic sauce?
There's a intrinsic attribute that's internally in the core lib source, but it's not
It's not in the ref
required
set?
to be. Yeah, it's not required to be in the reference assembly.
Okay.
I don't think the attribute's public, so I don't think it can be.
Okay. I guess that would be why it's a very faint bell. Alright, so we have those guys. Is there a non-numbered vector mask in here, or is that the one you said's in a different proposal?
It's at the bottom there.
Okay. I guess, yeah, I didn't look at all the creates with their argument, and I feel like there was something you came back and said maybe it should be something else.
Oh, the 64 one should take byte, not U short.
Okay, but the rest were right. So
Right.
I guess 128's U short. And
Yep. And then U int and then U long. Vector mask in particular, because it's variable size, it can't take a concrete integer type. So much like vector of t does, it exposes a crate that takes a byte array and a read-only span of byte following the normal set of 3. Where this is where it will read the first in elements up to the vector mask size. It will throw if the vector mask size is larger than the array provided, And in this case, it will treat it as hacked bits. So each byte will represent 8 elements. That way it can actually be converted efficiently. It is not, for example, how it would be with bool, whereas each element represents 1 element.
Are there Indianness issues with this?
No, we interpret because it's byte, and because we interpret it strictly as 0 through n bytes. There is no Indianness consideration there. There's no swapping or anything. It's treated as, for example, vector 128 is treated as 16 sequential bytes rather than as int 128 would be, which would be a single int 128 value.
Okay. Got it.
Do we need the array with, I assume the index is an element skip count?
Yeah, the start index. I think we just used index in the vector create API. We don't strictly need it. It's there because we've provided it for every other case, including with the new vector APIs for consistency, as far as I'm recalling.
Fair enough.
And when you're indexing into this, the number of items, the count is based on the t, correct? Not the number of, say, bytes in the vector.
Correct. It's
Okay.
It's based on the t, so vector, and it will be the same t. It will be the same count value as the corresponding vector of t dot count.
Okay. But that sounds like that's just kind of a sleight of hand we're doing ourselves, because the CPU doesn't really have a concept of that, correct? The CPU just has like a mask register. Is that right?
Right.
Okay.
It's the instruction that determines how many bits are read out of that register.
And then I think we glossed over it previously, but so get element is reading a bit out of the bit vector and then used with element instead of set element because it's returning a new value.
Right. Read-only pattern.
Yep.
What do things like LZ count, pop count, and so on do when you have, say, a vector mask of int as opposed to a vector mask of byte? Like, do they divide the answer by 4 when they return it to you?
They return it based on the count.
Okay.
So just as if you were to do extract most significant bits and then mask it down to the correct size and then do LZ count.
Okay, got it.
I didn't, but if you did, then great.
Yeah, so let's go ahead.
No, you go ahead.
Well, so the way I understand it, just to regurgitate this, is it is the number of elements, not the number of bits in the mask that are set to selected or true or what have you.
But elements and bits are equivalent here.
Well, I guess I'm thinking that a vector mask, a vector 64 mask of long will have a single element, but a vector 64 mask of long will have 8 bits backing it, 1 byte. Correct?
It will have 8 bits backing it, but it will be count 1 because we only consider 1 bit.
So I guess if I have a vector 64 mask of long set to all ones and I call pop count on that, it will return 1. But if I then call as byte and call pop count, it returns 8.
It would return 1 because only the lowest bit would be set. But there is also no as byte. No as byte that gets you a scalar byte. The as byte reinterprets the vector mask of long as a vector mask of byte, in which case the upper bits, the other 7 bits would still be 0, and so pop count would still return 1.
I thought in his
But
scenario he was
LZ
asking for the all bits set member.
Yeah.
Right,
So if I have a vector 64 mask of long, all bits set, and then I reinterpret that as a vector 64 mask of byte, that will not be equivalent to vector 64 mask of byte dot all bits set.
I don't think we would have to have that requirement. There's the internal representation, which is you can't get smaller than 1 byte, but then there's the concept of represented bits that you're actually interpreting for a given operation. And a pop count on a vector mask of long is different from a pop count on a vector mask of int. Because with long, you're only supposed to consider 1 bit, whereas with int, you're supposed to consider 2 bits.
Right. I guess what I'm saying is when you call vector of t dot as whatever, that is a reinterpret cast, correct?
Correct.
So why wouldn't vector mask of t dot as also be the equivalent of a reinterpret cast for symmetry?
So why wouldn't? So could you repeat that last bit?
So if I have a vector 128 of int, for instance, and I reinterpret cast it as a vector 128 of byte, presumably maybe I want to perform some masking operations on this vector. So I also have a vector 128 mask of int that I call dot as byte in order to turn it into a vector 128 mask of byte. Like, would that not also be a reinterpret cast for symmetry with the normal vector APIs?
Right, so it'd be a reinterpret cast. But what I was saying was that how we represent all bit set for long is we only would require it to be 0 or 1, whereas you could potentially also represent it as byte.maxValue because it's still.
I see. Okay.
Like that starts getting into you're doing kind of unsafe things where when you're reinterpreting. It's just like with reinterpreting an int as a float. Depending on processor configuration, you might have treat denormals as 0. You might have signaling NaN exceptions enabled, in which case passing it into a function could throw an exception. Of course, we disable all of that for .NET, but it's some other platform could have it enabled, like Unity or Mono or someone. And so there's always the case of when you're reinterpreting, you could potentially do something dangerous if you're not considering kind of edge cases that could come about from that.
So why do we have an as API that is a reinterpret cast if we're not guaranteeing that the bits will match up after that reinterpret cast finishes?
Well, the bits will match up. I'm saying that if you reinterpreted a vector mask 512 long all bit set that does as byte, that does not necessarily have to equate to vector mask of byte dot all bit set. We could make it that, but there wouldn't be a strict requirement that it be that, because the all bit set operation would be allowed to return 2 different values depending on the T. And then reinterpreting would be a straight reinterpret, and so it wouldn't require that they actually equate.
Right. So I think it's the specific the property all bit set that, since for in the case that we're talking about there are 7 don't care bits, and it's saying it's free to either set them all to asserted because it was all bit set, or that it's free to leave them all as 0 and only set the 1 semantic bit. And that's an implementation choice, which was done in the all bit set property, not the as.
Yes.
Yes, and I get that, but I guess I'm saying that if we're encouraging people through the as method to perform reinterpret casts of these things, all bit set probably really should mean all bits set.
Maybe. I mean, there's an interesting. So I guess I'll ask the question where it gets interesting is if you're on vector 64 mask of long, so there's only one semantic bit. What does the double equal operator do? Does it look at all 8 bits, or does it only look at one?
Semantically, it would only look at the one relevant bit.
What does it do? If you have two vector 64 mask of longs, and one of them is an as from a byte based one that actually set all of the bits, are they going to not equal, even though if you like print them, they would print as equal?
You mean if you reinterpreted a byte as a long?
If you right, so if you've reinterpreted or the register got assigned through something else, and so you're getting the value, I guess eventually as an as, is the equality operator looking at the 7 don't care bits, or is it looking just as at the register and just doing comp?
I would presume that we do it like bool does, which is that we would conceivably have to mask in the worst case, and then do the comparison, which still ends up being just a single operation. You basically and instead of comp, and then branch. But or in this case, you test and branch instead of compare and branch. But you would ensure that you would have to not consider the upper bits in order to ensure that the scalar and the vectorized implementations were equivalent.
Right. I mean, because really, if you get I don't know that it's going to be common, but let's say you get a return value that is a vector 64 mask of long. If it was reinterpreted from something else, can you do equal all bit set, and that means something, or is basically equal on these because of the as is now undefined, because this is the first time we're introducing don't care bits into the platform, aside from bool, which has always been weird and special.
We would ensure that it's well defined and that it only cares about the bit that's set.
Okay.
Yeah. I guess maybe this is something that we can delve into in more detail offline, but I guess my high level concern was there are lots of places in the code that I write especially where I perform is vector A, are the elements of vector A less than the values of the elements of vector B, for instance, and it will return a new vector where all of the elements are 0 or all of the elements are all bits set to 1. And then I can take that vector and reinterpret, cast it back and forth to do, for instance, a narrowing or a widening operation. And I can still be, confident that all of those bits are still there after the widening or narrowing operation. If we're now saying that I take all of that code that I used to have and I start using vector 128 mask instead, now those same concepts don't apply. Like, that to me seems like that could start leading people into a pit of failure, because we now have asymmetric behavior between two similar pieces of code.
So this is like vector of 3 and reinterpreting it up to a vector of 4 using the unsafe API. That is not compiler services unsafe, but the as vector 4 API that will allow a zero as vector 4 unsafe API that will allow a 0 cost conversion that leaves the upper bits undefined, where if you interpret to and back, you can do that as many times as you want and the value will be preserved. But as soon as you do an operation as a vector 3, the upper bits may change from what they were originally. They may not be preserved after you do another operation. And
that sounds fine, yeah.
And so if you had byte and reinterpreted it long and then back to byte, you'd have the original vector mask of byte still. But if you interpreted it to long, you did some operation and then converted it back to byte, then the upper 7 bits are then undefined, because the operation as long may have ignored them, or may have even done an optimization such that it overwrit them because it didn't believe they were important.
Is this because we're just trying to achieve some kind of mathematical purity within our APIs, or is this how processors actually behave in practice?
The processor doesn't really have a type concept. Independent instructions have concept of how to interpret the bits. There is no actual like of byte register kind.
Right. And I'm thinking back to when you do other vector operations like a simple comparison. If the comparison succeeds, every single bit that constitutes that element, wherever it happens to be located in the vector, is guaranteed to be set to 1. The processor doesn't say, I'm only setting the high bit to 1, and then everything else is undefined. Like, the processor guarantees everything is set to 1.
There's multiple cases where the bits are left to be explicitly zeroed, left as is, or sometimes even doesn't speculate or doesn't set date what the bits could be. That's true for hardware and even for just platform APIs. Like if you pass a byte to a method, it gets passed in a 32-bit register on 64-bit Windows, but the upper 24 bits are undefined, and so that's why the JIT always inserts MoveZX before it accesses that byte.
Right, I understand that.
In register.
But when I call pcomp, for instance, like when that instruction's actually emitted into the stream, like the bits are going to be 1 or 0 coming back out of that instruction. I don't like looking through the documentation. Like I'm pretty sure there's nothing in there that says the bit values are undefined when the pcomp instruction finishes. Right.
That's a case where it will state that it sets a particular number of bits and it will set them to one of two values. And in the case of vectorized comparison results, it will set it to 0 or all bits set per element.
Right, and I guess I'm saying, like, why don't we make the same guarantees within the masking APIs?
Because the masking APIs are a little bit more complex than that.
Yeah, I mean, I think we'd also potentially, given what these are used for, we'd potentially run into problems where the AVX 512 instructions, since these are a dedicated thing, that maybe they do one thing and now, ARM version of AVX 512 defines it a different way for a very similar looking operation, and it's down to which instruction did we pick to use for, mask bitwise and it's like, well, it might have cared and had a set them all to high or set them all to low if we're doing the wrong size. Again, that one doesn't look like it would happen with any of the operations that are defined here, but yeah. I can understand once you've left the semantic bounds of this type, we're not going to make guarantees as to what state that register looks like, so don't do operations and then cast down.
Because this is a cross-platform API, we're going to do everything to make sure the scalar and hardware-accelerated implementations behave the same. Mm-hmm. And in the case of something like all-bit set, as an optimization, we're likely going to have it return actual all-bit set for the underlying element, because that's just more efficient to initialize. But there wouldn't be a strict requirement that any implementation do that for all-bit set. Just like equals couldn't go and say for vector mask of long compare more than count elements, even if there's more bits represented, because that could then lead to non-determinism.
Right, and that was the concern. That was where my question was coming from, is basically is equal or not equal becoming an unsafe operation because of the as with the don't care bits. And if you say that it's going to basically always mask the answer down to the semantic bits, then that makes me happy.
Right. Maybe we could solve this by so the root issue here is that unlike vector 128, where the 128 means that you always get 128 bits and all 128 bits are used, outside of the couple instructions to say it's only going to use the lowest 2 elements or whatever, the lower half of elements. Vector mask is a case where we don't guarantee the size, and we just guarantee an element count. And so maybe we should call as byte unsafe or something instead.
Yeah, I guess to me it's surprising that for vector as is not a lossy operation, but for vector mask as is a lossy operation.
Well, it's not lossy.
You just said that if I go from vector 128 mask of int to vector 128 mask of long, for instance, like the number of bits that we're guaranteed to persist halves.
Well, no. So let me try and reiterate that. The as is a pure reinterpret cast. The actual byte value that was represented there will be preserved across any number of as calls. It's as soon as you do another operation with that as a different type that the irrelevant bits could be ignored by that operation. For example, equals, even if you had all 8 bits set, can only consider count bits. And so what the upper bits what the bits above count are don't matter, because we could never consider them, because that would break determinism.
Yeah, that's fine. Like I'm not calling as for fun. I'm calling as because presumably I actually want to do something with a value that I'm converting to.
Right.
So presumably whatever operation consumes a result of the as is only guaranteed to use however many bits of data are available.
Right. And when and for example, if you do let's say with element, because that's a good example. Let's say that you have a vector 64 long, and you say with element 0 true. The JIT would be allowed to throw away the upper 7 bits and only return a constant 1, because the upper 7 bits are irrelevant, and you have done another operation that didn't need to consider those upper bits. And so if you had the byte and then you interpreted it as long and then you interpret it back to byte, it would preserve everything. But if you interpreted it as long and then called with element 0 get element 0 and put it back to byte, it could differ, because you've done an operation other than a reinterpret that no longer has to consider those bits.
Yeah, that makes sense to me. Yeah. So that's the thing that was throwing me off then. And now that you've clarified that, I think it makes sense to me. I was considering that just like on vector, the as would be with preserving, whereas you're saying that technically for mask the as is with preserving, but as soon as you try doing anything with it, we're only going to respect the number of bits that's absolutely required in order to perform whatever operation you were trying to perform.
Right.
Which to me means that the as is potentially lossy, because again, I'm not going to call as unless I intend on doing something with the projected value. Like no one's going to call as from T to U back to T.
Well, so it's never lossy because this is a read-only struct, and so all things are new values. They don't mutate the original. You can't mutate the original because it's read-only. So it's never lossy. It's that irrelevant bits may not be preserved across against operations that aren't as.
Mm-hmm. That makes sense.
Yeah, but unlike the base vector types, where all the bits were always semantic bits and you're just changing what they mean, in this case you do have, when the t gets smaller and thus count gets bigger, that bits have a value, but it may no longer have been semantic. And so it's interesting that when t gets smaller, that the world gets weirder. I don't so we could talk about it as unsafe, but so is, as int 16 is also unsafe, if assuming that your t was bigger. And since we don't know what the source t is, we can't name them appropriately.
I would almost want to say that these should be called to instead of as, because you should consider them as potentially changing the underlying value. Where and you're right, Tanner. These are read-only structs, so it's not modifying the original struct. It's returning a new projection that, in my mind, has different underlying data, because it's treated differently based on how you based on what operations you call now.
Because rather than having these same bits interpreted differently, you may have access to more bits now, even if it is a zero cost conversion itself.
Correct.
Okay. Yeah, I would be fine with calling these to instead.
Okay, so on all the number types, we want to rename as of 2t's to 2 of 2t's, and then replace all these prefixes?
Yeah, I think so. If no one else objects, of course.
So along those lines, if we're constructing a say that we're calling vector mask of t.create, and we're creating a 128-bit vector of long, a 128-bit vector mask of long, and we pass in a read-only span of byte to the create parameter, we're only reading the first 2 bits from that, correct? And we're dropping everything else?
Right. Just like
Okay.
vector create does.
Okay.
Tanner?
Yes.
For the create, where we pass in the byte array or a read-only span, do we want it to throw an exception if there are not enough bytes to fill the implementation of the vector of the underlying bits, or do we want to like zero extend or something?
The way vector works today is it throws if there aren't enough.
Okay.
If we wanted some API that allowed you to leave the upper bits undefined, we'd have to follow the existing pattern of create unsafe. Like create scalar unsafe does.
Okay. And what about the opposite? If more bits are passed in than is necessary, do we just ignore, or do we
Yeah.
also throw?
We just ignore. We ignore more, we throw on too few.
Okay.
Is that for vector mask.create of here are some bytes, but there weren't enough?
Right, we throw if they pass in an array that doesn't have enough bytes, and we ignore upper if they pass in an array that's got too many bytes.
Yep.
Thanks for walking me through that. It makes a lot more sense after your hand-holding exercise just now.
Okay, so in review, all the is hardware accelerateds became static. They have to be. They wouldn't have compiled as is. We prefer vector 64 mask over vector mask 64. We would like Tanner to, or Tanner delegate to investigate what vector 64.mask would look like instead of just being a suffix. XNOR we're happy with. We renamed all the as's to 2's, and I theoretically fixed all of the vector in mask.creates, but if they're wrong, then hand wave it in the pull request. Is there anything else that we talked about that should be written down? Anything that we missed? Presumably vector 256 extract mask returner vector 256 mask. Got a lot of copy pasta. Anything else anybody wants to talk about, or are we good with approving, and then potentially reshaping to insert some dots?
I think by and large we're just going to have to experiment with this within the runtime and see what falls out.
Sure. That was. Does anybody have, shape or name concerns? Practicality is later. Okay. Yep. No new chat comments. All right.
Yeah, so
Intrinsics AVX 512 Foxtrot 73604.
yes, so now we get to the actual AVX 512 ISAs. So this proposal just covers AVX 512F, where F, I believe, stands for foundational. It's the foundational instructions. We could theoretically just call this AVX 512 if we wanted to, and it would likely never conflict. But the official ISA bit is AVX 512F. With AVX 512, there is a special consideration that comes up. So up until now, there has been a fairly linear relationship between a new ISA and what previous ISAs it implies. So SSE2 requires SSE. SSE3 requires SSE2, blah, blah, blah. With AVX 512F, it actually has 3 base ISAs: AVX2, FMA, and F16C. We don't expose F16C today, but that's some conversion operators to support half.
I need to clarify that point. That is, like, you will only have AVX 512 if you have all of these things, or was that any of these things?
All of them.
Okay.
So AVX 512F is supported, implies AVX2 is supported, F16C is supported, and FMA is supported. However, since we can only do single inheritance in .NET, and since we can't do something drastic like change all of these to interfaces so multiple inheritance does work, which I don't think we'd want to do anyways, we're going to say it just inherits from the largest and most centric of all of these, which is AVX2. Which means you won't be able to AVX 512 dot and then access FMA APIs, for example, but that's not a huge deal.
Wouldn't it make more sense to go with the most obscure one? Or I guess you're trying to increase your surface area availability as opposed to indicating nicheness. So I'm guessing none of those, the other two, don't extend AVX2. That they could be present without AVX2.
No, they both extend AVX2 as well.
But then, okay. So we really only have two necessary parents unless one of them happens to also extend the other.
Sorry, they extend AVX, not AVX2. They are siblings to AVX2.
Okay. Okay. I mean, I assumed that was true once you said there were 3. I just saying these things out loud to make sure that we actually all understand the same thing. And, I mean, I guess if we wanted to indicate relative obscurity, then I think we would pick the least common base class, but I think you're suggesting we go with the most common base class just to enhance usability. Right?
Right, but we want to show the most direct inheritance path, the most prominent one.
Okay. Rather
than show or expose obscurity.
Okay. So before we actually get to that line, I see that you've added an enum in a non-namespace, and it's using numbers that presumably only apply to some particular zone of ISA. So where are you actually proposing that?
So this there should have been a namespace system runtime intrinsics x86 there. I thought I had done it as a top level namespace declaration, but apparently I did not. Maybe I copy pasted and then accidentally removed it when I was doing cleanup this morning.
Okay, so this float rounding mode only applies to IA32 and derivative architectures.
Right.
Okay, because I was concerned that we were adding something generic using numbers that we shouldn't. But
No, this is specifically an x86 rounding mode. Enum.
okay.
And it's
Chat
similar
asks,
to the float comparison mode enum we have in the same namespace.
Okay, yeah, I was just concerned it was being overly general since I couldn't see where it was supposed to be contained. Would a future ISA like AVX 512CD derive from AVX 512F or AVX2?
Derived from AVX 512F because it requires F, and it only requires F, plus everything that F implies.
F implies float, except for on this one type. Apparently, they need Intel needs to hire us out so we can help with their naming before they propose these ISAs.
No, it's great. I love it. F stands for foundational.
So,
Math foundational.
Yeah.
Okay.
So the float rounding mode is there because so prior to AVX 512, if you wanted to change rounding mode, so if you didn't want to do the default IEEE semantics of round to even, you would have to go and modify the floating point control status register, execute your instructions, and then switch the control status register back to whatever it originally was, which, quite expensive, quite complex. You have to do that and manage it per core. .NET doesn't support it at all. It's quite not nice. With AVX 512F, almost all of the floating point instructions now have the ability to encode exception handling and rounding information on a per instruction basis, without actually going and modifying the publicly readable control status register. And so that's what this enum exposes. So if you'll notice the comment on the right side, this is actually, the to even represents a combination of two flags. One is the round to nearest int, so which is just to even, and then there's also the no exception handling bit. We kind of have two options we could do here, depending on if we wanted to support the theoretical scenario of .NET supporting exceptions more broadly, floating point exceptions more broadly in the future. And we could define this enum as it is and say we'll never support exceptions, or if we do, we'll call them something like to even no exceptions, or some other name that's less confusing. Or we could expose it more like how C does, and we could actually expose it would be to even with exceptions.
Yeah.
With exceptions. Or we could do more like how C does, and we could have to even and then to even without exceptions. The AVX 512 APIs, most of them only support controlling the rounding, not also the exception bit. There's a few that also support controlling the exception bit, and some that support controlling both. For the purposes of the proposal below, we only expose float rounding mode for the cases that allow rounding, and not for the cases that only allow exception handling. But that's kind of an initial consideration, and my leaning would be we call these we just have these as to even, and then we call it to even with exception for the other if we want to add them in the future.
I agree.
All right. And then,
so on the operations that take them, just before we move too far, I assume that float rounding mode is actually going to be, shouldn't there be an attribute on it of like, dear God, give me a constant? And then
So we have that attribute now. It's not going to prevent the code from executing. It's just going to ensure that it's inlineable as a single instruction table.
right. So when you receive a variable in this case, is it going to fail if you're not one of these 4 values, or is it going to just do stuff?
Is Jeremy cutting out for anyone else?
Yeah, I'm seeing the same thing.
Oh,
Okay.
I was going to say you were cutting out for me, so, but apparently it's me. So if you call float rounding mode either with a constant that's not a defined constant, which I'm sure the JIT could just smack you down here, or if you call it with a variable that is not one of these 4 values, what is the behavior going to be?
We throw argument out of range exception.
Okay, so we are going to do a
That
very strict, we're not going to let you assert the exception, or we're not going to let you clear the no exception bit. You have to do only the things that we understand.
right.
Okay, thank you.
That's how we do it for all of the things that expect constants when you pass in a non-constant, is we go down a slower path that actually validates the variable and does the right thing.
And even though that attribute hasn't been created or approved yet, we should just assume it's going to be applied to these APIs at the right parameters.
So the attribute has been approved, as has the analyzer. The analyzer's been partially implemented, but it didn't get merged for .NET 7, and it's not merged yet.
Okay.
But the general intent is effectively any API where the underlying hardware instruction requires an M8, we would put this attribute on it to say, warn the user if they're not passing in a known constant.
Okay, I think for stuff like that, we could probably just do like a separate issue and approve it like within the issue itself. We probably don't need to spin up a whole discussion for it.
Yep, that was my general plan. When the analyzer was actually available, it basically just then we get to the actual API. So we've got AVX512F, we've got the is supported property. This first chunk listed under SSE through SSE42 is APIs that were originally introduced in SSE through SSE42, but which now support 512 bits. So for that entire section, there's no new concepts outside of the float rounding mode overload. Everything else is just the existing name, just taking vector 512 where relevant, or float rounding mode in the case it's an API that takes that. So with the float rounding mode, as you can see on the fourth, on the second add there, we have left, right, and then float rounding mode is the last parameter, so it becomes proper positioned after the other overloads.
Do we not need 128 and 256 bit overloads for add that take the floating point rounding mode?
They don't have it.
Oh,
you
so
only get it for vector 512.
Okay, got it.
Except for add scalar, which are listed here, because those do have vector 128 that take the rounding mode but only operate on one scalar.
Mm-hmm. How about for the integral add method group? Like, do we need vector 512 of byte short, anything like that?
Nope. This is the full set of APIs that are exposed for it. So the reason that it's just int and long is AVX512 is broken up into kind of 5 core ISAs that are defined as part of the x86, x64, v4 baseline. V1 was the original x64 platform. V2 was everything up through SSE42. V3 is everything up through AVX2 plus FMA and BMI, and then V4 is AVX512 plus BW which stands for the versions of the instructions that support byte and short lengths. DQ, which is not Dairy Queen, but rather the instructions that support int and long. And then CD, which is conflict detection APIs, largely just operating with masks in a few places. So there are actual APIs that take byte and others, but they're part of AVX 512 BW.
Okay.
Notably, DQ, even though it's supposed to be int and long, a lot of the int and long instructions are part of the foundational set and not DQ. But the split in the actual proposals are correct.
Okay. And I guess the other follow-up question I had is, I see some long APIs in here, and they do properly belong here instead of in the x64 nested type, correct?
Right. For the most part, even on 32-bit, the instructions that operate on vectors of long work on 32-bit. It's the ones that return a general purpose register that's 64-bit value, like convert to int64, which returns a 64-bit scalar. Those ones are 64-bit only.
Okay.
And for add, I don't remember what we've done on the other ISAs. Do we want both int and uint, or are they actually not defined for unsigned integers here, or what?
Let me open my notepad and double check. I think we might actually want uint and ulong.
Because clearly for abs that doesn't make any sense. But
right.
But it add and maybe the and not, and because I feel like these aren't like and not don't feel like they're semantic on the signedness. It's the same instruction for both value types. So
right, and add doesn't doesn't do flag setting, so the signedness doesn't matter there either. So yes, for many of these APIs that take int and long, there should be a uint and ulong overload as well. And it completely slipped my mind that I should be adding those for this proposal.
okay,
Thankfully, I didn't forget them in the next proposal. Those ones I remembered them in.
And so just making sure for consistency in the other ISAs, we have done all the groups and not make somebody do as away the signedness.
Correct.
Okay.
For APIs that support both int and long in the 32-bit versions, we still don't want to add int overloads, correct?
So we have added int overloads there, but we have approved but not implemented int overloads for that. I likewise have not included them here because we've not implemented them at all, and so they need to be a separate work item from from the proposal that's going to unblock Intel. But there will be a separate proposal that covers inint and inuint overloads for these APIs in the future.
Okay.
Yeah, because I see like here we did get int and uint both came in. Just looks like some of the the mathy ops. I assume that things like convert to vector t, that we have these in other places, or is this new here? But really, this is what are the new words? Like we've seen add scalar. You understand what they mean.
Right. So for SSE through SSE42, there are no new concepts outside of the float rounding mode.
Okay.
These are all APIs that we've already reviewed and approved for Vector 256, just taking 512, or in the couple cases involving scalars that take float rounding mode.
Are there any concepts that have been removed? For instance, I don't know if there's like a move mask B equivalent for 512.
That has been removed because there will be a separate proposal covering the masking registers.
Okay.
Although if we have time, we're going to discuss the masking concept a little bit, just because of how it impacts the proposal. We don't want to add 4 extra overloads per API. And so if we have time, we'll end up briefly discussing if we can use default parameters there to cut that down.
Okay. And yeah, I don't have any other feedback on this block of APIs then.
Well, so because you've mentioned default parameters, should the things that take a float rounding mode get defaults, and presumably the default is 0, which is use the control status registers?
So the default would be 2 even. So 0 represents 2 even with exceptions. Because 2 even equals 0 x8 is the same as f round no exc, because 2 nearest int is the actual 0 in C, and in the way the instructions are the actual bitwise encodings interpreted.
Okay. Is there a float rounding mode option that is for AVX 512 that is do whatever the control register says?
I'm not sure off the top of my head.
Because really the question is this add, is the add that doesn't take it, is that doing to even, or is that doing whatever the control register says?
It's doing what the control register says. And there's a separate encoding that you use that's not representable by the enum that indicates
Okay.
not to.
Okay. All right. So I feel like it's asked and answered. Should we add a do what the control register says and make that the default? Or I guess in this case it would actually be do. Yeah. Should we do control? And you're saying no. We did get a question in chat. If Intel calls it round to nearest, why do we call it to even?
Because 2 even is the clearer and more appropriate terminology. Round to nearest int was the C++ terminology, and we have deviated from the C++ names in many cases. Like we don't do underscore underscore add underscore ps. We have given much more friendly and intuitive names for people to use, since we aren't limited by C naming conventions. And in this case, 2 even is more clear about how the behavior rounds than 2 nearest int is, because 2 nearest int is not actually nearest int.
Yeah, that's fair. Hopefully that makes Kevin happy. But okay, so we don't want to default this. I'm still scribbling in some U's, even though I left a note that said just fix them.
Yeah, we theoretically could default them by doing something like using a sentinel value of -1 or something, and just force casting it to the enum. That would get rid of some overloads here, but then we have inconsistency between some APIs, like on whether there's a default parameter or not. I'm not sure it's worth it, but I'm also like, if enough people say that that's fine, then
well, I mean, this is especially once you said that there's going to be defaults being added in another proposal, and if that's the first time we're using defaults in intrinsics, then it's should we just rewind an issue and talk about it here? And,
Yeah.
Again, I don't have a vested answer, so I don't really care. But it came up, so it seemed like a question to ask.
Yeah, makes sense. And then after this section, there's AVX to AVX52, which is in a similar setup of its just APIs that we've already exposed, but 512-bit variants. And then we get to new APIs under the AVX 512 section, which are the ones we actually need to care about.
All right, see lefts and rights and addresses and counts, and thank you for doing the words this time.
Yep, as far as I'm aware, I did all of them correctly too. Yeah, so right there, you just passed it. AVX 512. So here's where the new concepts start. Align right isn't itself necessarily a new concept, but it is a new concept that it takes 2 parameters, I believe. But it's just left and right. Broadcast to vector 512 is a actual new concept. So all of the broadcasts we've exposed so far are broadcast scalar to vector. And so they'll only read the lowest element of memory and broadcast that up. These broadcast to vectors, they broadcast the entire vector. So broadcast to vector 512 that takes a vector 128 of int replicates the entire vector 128 4 times. Broadcast to vector 512 that takes the vector 256 of double broadcasts the entire double into the lower and upper half, if that makes sense.
No, but I'll pretend it does.
It's a clone stamp tool. It's great.
Convert to uint32 is the unsigned equivalent to our existing convert to int32. Likewise, convert to uint32 with truncation is the counterpart to the existing convert to int32 with truncation. We then have some APIs that discuss conversion with the concept of saturation. So convert longs down to bytes with saturation, uints down to bytes with saturation. These are extensions of existing concepts, but they are and naming conventions, but they are unique to AVX 512. There is no true equivalent otherwise in the lower ISAs. And so it's not just a simple 512-bit extension of an existing API we've approved.
Is this a case where we would actually want to have a single family of APIs and then have our own concept of a control value that's passed in that says, like, here you saturate, here you truncate, and so on?
We have not done that elsewhere. These are unique instructions that don't take any kind of flag or enum. And so we already have a plethora of APIs lower down in SSE through AVX2 that follow this exact same pattern.
Got it, because I'm looking through the ARM64 stuff that was done, but I guess we didn't really take control bytes there, did we? We just added different overloads in the methods.
Yep.
Okay.
And notably, the main difference between x86 and ARM here is that x86 has been built up, over the course of 24 years now, since SSE was introduced in like 98 or 99. So it's a lot of iteration on top of adding things as needed across generations, whereas ARM64 was largely they redid what was originally their Neon instruction set into a single advanced SIMD instruction set in 2012, and so they were able to group everything together with the 20 years of hindsight that every other platform had built up. But there, for these converts, there's no other real new concepts or naming conventions. Just they're unique to AVX 512. The first new thing is fix up, which is there at the bottom of the screen. Yeah. So this instruction is v fix up im ps or pd, and what it does is it allows adjustment of special floating point numbers. So for example, you can fix up you can say any element that's a nan or a 0 or a +1 or something else. You can go and fix it to be this other value. And the way that works is it takes a two input vectors left and right, and it takes a table of values, which is the third vector there, that specifies what value, how the value should get fixed up effectively. And there's a fairly complex algorithm that describes it, but that's the way that it operates, and allows you to go and take these special token types of not a numbers or zeros or infinities or ones, and then fix them up to be a desired value instead, which is very useful for accelerating, for example, math functions to handle edge cases branch free, and without having to check every potential edge case you need to handle, because the table lookup just does it for you.
Okay, I'm looking at the instruction docs right now, and I think you had mentioned earlier we're not accounting for exception reporting mechanisms here, correct?
Correct, which is why
Okay.
we don't have the comma SAE.
Got it. Okay.
And I've looked, and for reasons that befuddle me, we have apparently decided in this platform that fix up is a single verb and not a compound verb phrase, so the U should be lowercase.
Yeah.
This is wordsmithing, I guess.
Gather is not necessarily a new concept. There's somewhat of that concept in lower. Notably, that gather vector 512 under float, I seem to have swapped the address and the index, likely when I copied it from native. But it's basically just the opposite of scatter, and it takes a base address, it takes the indices that you're gathering from, and the scale or distance between the indices at which you're gathering.
So gather 512, the pointer should be first.
Yep. Native takes the indices first, but the actual instruction encodes the pointer first, and taking the pointer first matches how we've done our existing scatter APIs and other APIs that deal with addressing.
Fair enough.
Then we have get exponent. This allows you to extract the trying to remember off the top of my head, the unbiased exponent, I think, from the floating point representation and represent it as a floating point value. And then get mantissa effectively allows the same, but it allows you to control how how edge cases are represented by specifying an interval and a sign control.
Permute var.
Right. So for permute var, we use the term var to mean variable rather than having to type it all out, because that's the naming convention used by the instruction and the C API.
Oh, looks like we have a permute var 8x32 already on AVX2. So
Right. So these are extensions of the existing concept. However, instead of taking one input, they take two inputs. And so it's a two input permutation using non-constant indices. In the case of 8x64, it is the reason it is 8x64 is because it takes two inputs, and therefore you have 8 total 64-bit inputs.
Yep.
And then the same applies to 16x32. Then we have explicit rotate left. Rotate left variable, which matches the convention of shift left and shift left variable that we have elsewhere. Then we have reciprocal 14. So the 14 is kind of like that instruction we reviewed for ARM the other day, where we said it's a specific convention to that processor. The 14 here indicates that it's doing a single iteration. So this is doing a single iteration with a relative error of no more than 2 to the power of negative 14, which is why the 14 is there.
I assume that the Intel assembly has a 14 in the instruction encoding.
Yep, it's VRCP14PD.
And then presumably the same thing at reciprocal squirt 14.
Yep.
Yeah, so just FYI, I went through and I started adding uint in places that I was pretty sure it would, and then at some point I stopped and just started adding comments of like uint question mark.
Yeah, that works for me.
So like on shuffle, I assume shuffle doesn't care, so that there should be a uint and a ulong here, and on scatter and etc. But any that don't need them certainly don't add them, and I just did it as a hint.
Round scale and scale are both effectively optimized versions of specific C runtime math functions. If I remember correctly, it's the opposite, or it's equivalent to scale, Scalbian, and then the opposite of mod FF or F mod F, one of the two. But they're just effectively additional floating point operations that allow that acceleration, additional scatter APIs, additional shuffle APIs, and then ternary logic, which is one of the most fun APIs provided by AVX 512, as it allows you to do bitwise ternary logic across the entire set of inputs. So you can basically specify what kind of logic you're wanting it to do, whether that's and or basically any other kind of bitwise arithmetic on these values. And then the 64-bit specific versions of these ISAs.
Oh, right, because I asked, wouldn't the 32-bit drop mode turn them off, and you said no.
Yeah. And
Yeah,
that's effect. Oh, go ahead.
I was going to say, I see what you mean now about the x64 APIs either consuming or returning 64-bit register values.
So on the 64-bit ones, I have the opposite question. Convert scalar to vector 128 double only has unsigned input.
Yeah, in this case, it's because the ones that take the signed inputs were already provided by a lower ISA. So
So the signedness actually matters in this instruction?
right, because it's converted.
Oh yeah, because you need to know if it's a negative double or a positive double. Okay. Yep. Makes sense. Just my brain has been scanning this proposal for integer types, and anytime they didn't have a friend. Okay. Was there anything that someone wanted to say that they haven't said yet? Was that for an open question? I assume we still have people attached. Yeah. And is there anything that you thought we were going to care more about that we didn't, Tanner?
No.
Okay.
It sounds like we're not gonna have. It looks like we're not gonna have time for VL, which was the last proposal, so we can get at that next time. But I did want to briefly just drop the concept nugget. Low. Yeah, it's basically these, but 128-bit and 256-bit variants. But I did want to drop the kind of nugget of information around the masking concept. So I'm gonna drop this in chat real quick, but that's of course terrible. But the general premise is that AVX 512 supports masking. With the masking support, every single API that we've expressed here, or almost effectively every API, now gets at least 2 additional overloads. In the case that you're dealing with the with floating point and therefore rounding mode, it gets 4 additional overloads. That in effect is that you get an overload that takes a mask that specifies how the result, how the computed result is merged with a with the value of either 0 or with an existing vector. So in the case of 0, it means that any elements that aren't in the mask become 0 in the destination. And in the case of the non-zero source, you end up merging with whatever the other values are. With 0 basically being a specialized encoding. And so the thought here is for native, they take source and mask as the first 2 parameters. The general thought is that we should instead change it around so that source and mask are the last 2 parameters. And in particular, source will be the last parameter, and we will default it to 0, or default rather, which is 0. Which means that we don't have to expose separate concepts for 0 merge masking and value merge masking. The JIT can instead optimize it based on when the input is 0.
And the 2 are equivalent, not specifying it and actually specifying a vector that happened to have the value of all zeros. So an existing variable that has that same concept instead of a constant expression of default of t.
Correct. And so it would allow us to have the number of APIs we need to expose in addition to what's already here.
I remember in the past we had concerns about the JIT not necessarily being able to optimize vectorized APIs all that well. Do we think all of those concerns are addressed such that using default values would be acceptable?
Default values have never been the concern.
Okay.
Default values are just constants, and the JIT can see all of those and import. In the case of vector constants, we now have a dedicated vector constant representation in the IR. That way we can always see that something is a vector constant and optimize it accordingly.
Okay. I actually had a question on something at the very end of the APIs, just before the x64 block. There's a function group called ternary logic.
Mm-hmm.
That control parameter is a byte. Do we want to leave it as byte instead of an enum with friendly names?
Potentially. It might be worth considering whether an enum is good there. But I don't think there is a official set of names for those options in C. And I believe that it's a little bit more complex because it's effectively 3 bits, or it's a set of bits, not just like 255 unique values, or a small set of unique values rather.
So we would expect that most callers would just go to the documentation, look up in the table whatever row they actually want to hit, and then type that value in.
Yeah.
Okay.
This is kind of similar to shuffle, where in C there's a helper called _mm_shuffle, which is a macro, which allows you to specify 0, 1, 2, 3, and then it will create the bit mask, and it will always be constant. And there's a proposal somewhere that we also provide a similar create shuffle mask constant API that works similarly for .NET, but which we've not reviewed and we've not gotten in yet. But where the alternative would be, we would expose some enum like shuffle mask, and we would have to define all 255 possible or all 256 possible entries, and they'd be named like XX, XX, X, XX, XY, XXXZ, all the way through WWWW.
Mm-hmm. Okay.
Which isn't a great user experience in either scenario.
No, that's fine.
Yeah.
If application developers care, they can always just define their own const for these things and pass them in.
Yep.
Okay, so I marked this one approved, so we got through 3 of your 4. And cool. So yeah, it is lunchtime and I am hungry, and we have wrapped up an issue, and therefore see people next week. Same .NET time, same .NET channel. Huzzah.
So Jeremy, I will. We probably don't have to review VL next week. I think there's enough here that we can be unblocked for a while, but I will work on getting the vector mask, the proposal up that takes vector mask with the defaulted parameters, so we can have the number of APIs we need to expose, and then we'll work through getting up the proposal around BW, CD, and DQ, and then we should effectively be done with the core v4 baseline that we want to get in for 8 total. There's a handful of other ISAs that we'll want to review at some point as well, but they're less important for 8.
Okay, but So for next week, you're saying
Yeah,
you're,
we should
you're not
be
going to
good-
drag Anthony back, assuming that I'm remembering what his name was. Is he still attached?
Yes.
Everybody's a very small pixel on my screen right now. Yeah, so if we're not going to go ahead and drag him back, then we would just go back to in order, and so it'd be, these things up here.
Yeah, and then I think we can we can set up another dedicated review session after I get the other proposals up, and we can, I think, get through most of those in this same day and hopefully be done then.
Ah, yes, I can't see the window in full size. Okay, well, thank you for joining us, Anthony, and yeah, so next week back to just things in order, and then at some point we'll have another brain melting day of going through more processor intrinsics.
This wasn't that bad. I mean, we had that digression on like how many bits of data are actually stored in the mask that are usable.
Yeah,
But I thought it was a useful discussion though.
I can't think of another place in .NET where we've ever had an actual don't care bit. Again, aside from Boolean, and Boolean has always been extremely special. But yeah, I don't know. So yeah, Kevin, if you're still watching, looks like we might get to some of your things next time. So hopefully you're watching next time too. All right, ladies and gentlemen, I am going to close things down because I am hungry. See y'all next week, or for those of you that I work with in whatever meeting we have next. Ciao.
Thanks, everyone. Appreciate it.
Mm-hmm.